Welcome you all to this digital communications class. In this class, we will be discussing about the various aspects of communication, the signals, the various types of signals, and what is needed for a proper communication process. So, basically, what is this communication? We must be hearing about different types of communications, verbal, non-verbal, and by means of different signals, symbols, and so on. In case of electronic communication, the information that you send from what is known as a transmitter to a receiver is referred to as communication. So when a signal is being sent from one place called a source and it is reaching the destination called the receiver, there are many things in between, that is a communication channel, communication medium, and so on. So there you have encoders and decoders as well. So before we go into the details, let us try to understand what is the signal that we are talking about. Signal is something which is a function of time. It can be either an information or it can be a data. So this information what we are talking can be telephonic conversation, music, speech, and data. It can be by means of a circuit, the pressure measurement, temperature measurement. So measurement of temperature, pressure, these are all values that you are measuring. That becomes a data. Now how do you, if you are performing an experiment where you want to monitor the temperature of an oven or pressure in a particular column or any analog parameter that you are doing, and that information, the output of that circuit will be the data, and that you need to give it to different transmitters and receivers. So basically what we are talking about, information is something which has to be communicated between the source and the destination. The source can be the transmitter, the receiver is the destination. So now when we are sending this information, what you need is, sometimes you can send the information as it is, you can send the information in analog form, or you can send it in digital form. Analog form basically is speech, music, etc. These are all sent in an analog form. Suppose you want to send an information in a particular code. In intelligence and military applications, they won't send the information directly. They send it in the form of coded signals. So before you send the signal, the information has to be coded. So you need encoder. We studied these encoders, decoders in the last semester. So similar circuits are employed here to code a signal. That's known as encoding. This is done at the transmitting station. The signal is carried, and once it reaches the receiver, it has to be decoded again, so that the receiver will be able to understand. So these, and in between you have what is known as a channel for communication. So channel depends, this is a medium. So the amount of information that you are sending, the rate at which you are sending the information, and to what distance you are sending, these are all the parameters which govern the channel, and we define that as the channel capacity. And the information sent is measured in terms of what is known as bits per second. Okay? And baud rate is the rate at which it is being transmitted. So these are the various steps of communication. You already have some familiarity. So now let us try to understand what are the different types of signals. So a few examples of the signals are electrical equivalent of a speech or voice as obtained at a output of a microphone. Okay? And electrical output used to sense the temperature furnace or TV signals. All these are ECG signal. Very importantly, ECG signal also is a signal. So when these are the different types of signals that we are talking about, all the signals what we discussed are function of time. That means they are function of a single variable time. There may be some functions or some signals which can be a function of more than two variables. So suppose you are taking electrical charge which is distributed over a surface, then the signal is charge density, and it is a function of space. So like this we have different signals that are coming. Now what is a system? When you say signal, what is a system? System is something which processes the signal. So that means you are sending some input signal to a system and you are getting something at the output. So now what is the signal and what is a system? Signal is something which is a voltage signal. It can be voltage across 2 points, or it can be suppose magnetic lines of force you are considering, that can be a system. You take a magnetic compass, you take a bar magnet and you plot all the lines of force. So there the system is taking a magnet, drawing that becomes a system. Or if you are taking a photograph is a signal or an image. The color, the intensity of the picture will be the signal. Similarly, a video signal also. So these are all different ways in which the information is being transmitted. Now, when the information is being transmitted, it has to be processed. To process the signal, what we need is a system. So an oscilloscope, a computer monitor, or a capacitance for that matter, to measure the voltage across and so on. These are all the systems. They are basically instruments which are used to see or to process the signal. Now, what are the systems that we talked about? You can have an electrical system or a mechanical system. If it is a mechanical system, you give some input, give it to mass, and you get some output. Now, what is the input that you are giving? You are applying some pressure on the mass, and the force that the pressure means the force which you are applying on the mass induces what is known as acceleration. That is, F is equal to ma. What is F is equal to ma? That is Newton's law of motion. I think you are all familiar with the Newton's laws of motion. So we write this as F is equal to mass into acceleration. So you are applying the force and then the body is set into acceleration. This is a mechanical system. The signal here is acceleration. You are setting the acceleration. So the output you are getting, it is being set. Similarly, in an electrical system, you give it a capacitance, give a square wave, the output across the capacitor will be a spike here. So what you are seeing here is the output across the capacitor. So this is how you differentiate between a signal and a system. So now let's see, how do you classify the signals? The signals can be classified into there are various types of signals, but we consider our study here is limited to only these many signals: sinusoidal signals, exponential signals, unit step and unit ramp, continuous time and discrete time signals, analog and digital signals, periodic and aperiodic signals, energy and power signals, deterministic and probabilistic signals. So let's concentrate mostly on some of these signals. What is a sinusoidal signal? A sinusoidal signal is one which can be represented by a sine or a cosine. So a sine wave is represented by a sine omega t plus phi or a cos omega t plus phi. Both are sinusoidal. And this a is an amplitude, omega is the frequency, and this is phase. So you can write this angular frequency as 2 pi f and so on, and the phase angle is theta. Okay, so how do you represent that? You represent cos 0 is 1 and cos omega t minus theta. This is the way which is displaced by a phase angle of theta. This is how you represent, and the conversion between the radians and degrees is like this. 2 pi radians is 360 degrees, pi is 180, pi by 2 is 90, pi by 4 is 45, and so on. Similarly, you have exponential signals. Exponential signals are given by y is a function of t is e power alpha t. So you have seen growth and discharge on capacitor inductors are represented by this exponential, this decays and growth. So if alpha is less than 0, it's a decay. If alpha is greater than 0, it is a growth. Basically, we also represent these for radioactive decays. Okay, so this is how it is decaying. This is how the signal is growing. Then unit step function. As the name indicates, it has a magnitude of 1. For all values of t, all these functions are drawn with the time on the x-axis. So for all the signals for t greater than or equal to 0, u of t is 1 and it is 0 rest of the time. So this is how you represent that. Unit rectangle is a very popular one, and you represent this as RECTT, a function of t. This is 1 only for a very short interval of time between minus half to plus half, where its magnitude is 1. For the rest of the time period, it is 0. So this is about this. Then we talk about continuous. This is a very important classification. Continuous time and discrete time signals. Continuous time signal is a signal that is defined for every value of time t. For every value, you can divide this interval into infinitesimally small values here, and then you can just divide this here like this. Slice this, and for all these continuous values you have a single value function. So this is how you represent a continuous time signal. Then discrete time signal, a signal that is specified only at discrete values of t. So continuous time is like your telephone and radio signals, and discrete time is like your let's suppose you are doing internet usage and you want to study how your internet usage is going on for a week, for a period of 15 days. So you can just say morning 9 to 10, how is it? From 10 to 11, how is it? From like that, at different intervals you are taking, then it becomes discrete. It's not continuously, you are not monitoring. At every hourly or every half an hourly you are watching. Or stock simulations when they do, that also is discrete time. At different time intervals you will be doing. Or it can be rainfall if you are observing for a month, temperature of a month. And this information, actually when you can do a little project, monitor the rainfall for a period of 1 month, and then predict that, and then try to do some analysis, and that will be the most useful thing for the farmers. So likewise you have different signals here. Examples of signals: this is analog, continuous in time. B, digital continuous. This is digital signal. Discrete. Digital and discrete are similar. Similarly, analog and continuous are similar. Analog discrete and digital discrete. So it's analogically, it's continuously increasing, but discrete intervals of time. This is discrete, but also digital. Now, having known what is analog, continuous and discrete, let's now discuss about analog and digital. Analog is something similar to continuous, digital is something similar to discrete. They are similar but not same. So analog is one whose amplitude can take on any value in a continuous range. That means it has infinite number of values. Digital, this is a signal whose amplitude can take only finite number of values. So these are all analog, your amplitude modulation and all are analog. This is discrete. So this is how you define these two signals. Then periodic and aperiodic signal. This is periodic. If a signal can be represented by this for all values of t, f of t is equal to f of t plus t naught, then it is said to be periodic. That means this signal remains constant or unchanged when time is shifted by one time period. The time period is given by t naught. It must start at minus infinity and continue forever. So that means t plus t naught, 2 t naught, m t naught, where m is an integral multiple integer, it remains the same. So by periodic extension, this is 0 to 5, like this, you are just repeating. 6 to 11 it is repeated. 0 to 6, 6 to 12, just getting a repeat. So this is periodic. The one which is not periodic is referred to as aperiodic signal.